Okay, let's look at the test. The geometric mean between 9 and 11, that's the geometric mean, which is 3 squares of 11. Here, we want to use our inscribed right triangle theorems. There's 2 of them. This one we want to find PS, so we're going to use the altitude. Well, the altitude, PS, is the geometric mean between the 2 parts of the base. And so that's the square root of 40, which is the square root of 4 times the square root of 10, which is 2 squares of 10. This time we're using a leg, so the leg is equal to the part of the hypotenuse closest to it times the whole length. And so that's just the square root of 33, which is letter D. Find y. Well, we have a leg again. So 6 is the geometric mean between the side of the hypotenuse closest times the whole length. When I square both sides, equals 16 plus 4y. So 20 equals 4y, y equals 5. Find the length of the hypotenuse of a right triangle whose legs measure 6 and 5. So we just need to use Pythagorean's theorem. 6, 5, this is what we're looking for. X squared equals 6 squared plus 5 squared. So that's 36 plus 25, which is 61. So x is equal to the square root of 61. Number 6, this is not an inscribed right triangle. This is just an isosceles triangle. And we know that in isosceles triangles, it splits the base, the altitude does, in half. So this piece is 5. So again, I know x squared plus 5 squared equals 64 squared. Just Pythagorean's theorem. So x squared, 64 squared. Let's try 64. Equals, what's 64 minus 25? 39? 9 is 30, yep. So square root of 39. What set of measures could represent the lengths of the sides of a right triangle? So all we have to do here is plug each one of the answer choices into the Pythagorean theorem and see which one works. But this one's the easiest because I just square 3 and square 5 and see if it's equal to the square of 15. It's not, so it's not this one. This one, if I square 49 or square 7 and square 17 and see if that's equal to 24 squared, and it's not. Here, 8 squared plus 15 squared is not equal to 16 squared, so it's A. If I square 3/4 and I square 1, I add that together, I get 5/4. Or square 1 and 5/4, I get 3/4. Okay, find C. You could have used Pythagorean theorem, but if you guys remember your 45, 45, 90, if the leg is 9, the hypotenuse is 9 squared is 2. If I want to find a perimeter of a square where the diagonal is 16, well, a square, the diagonal cuts a square into 45, 45, 90. I have the hypotenuse, so to get from the hypotenuse to the leg, I divide by the square root of 2 and then rationalize. So it's 16 square roots of 2 over 2, which is 8 square roots of 2. That's one side. And then I do that times 4 because I want the perimeter. Just add all 4. So 32 square roots of 2. Put that in the calculator. Thank you. 45.3. Next one is a 30, 60, 90. We're trying to find the side opposite the 60. And I've said several times it's always easiest to find the 30 first, and then you can go either way. The 30 is always half the hypotenuse, so this side is 6, which means x must be 6 square roots of 3. Next, this is not a 45, 45, 90 or a 30, 60, 90, so I've got to use trig. And I am given adjacent and hypotenuse, so I use cosine. So I just take 12 times cosine 42. .9. Next one, opposite over hypotenuse is sine. And I'm finding an angle, so I'm going to take the inverse sine. Inverse sine of 6 over 11 is 33 degrees. If a 24-foot ladder makes a 58-degree angle with the ground, so this is the ladder here, and it's 24 feet. This is 58 degrees. How many feet up the wall will the ladder reach? So I'm trying to find that. Well, that's sine. (24) sine 58. 21.2. Okay, I did something wrong. (24) right, sine 58. 20.4. There we go. A ship's sonar finds the angle of depression to a wreck. So here's the ship, here's the wreck, and that is 13.2 degrees. If a point directly below the ship is 75 meters, how far away is the ship from the wreck? So I'm trying to find this. This is 13.2, so I'm going to use tangent. So I've got to multiply and then divide. So it's 75 divided by tangent 13.2. 319.8. Next, find the angle of elevation of the sun if a building 125 feet tall casts a shadow 196 feet long. And I'm trying to find that. So tangent again. And I'll use inverse tangent. 32.5 degrees. Still with me? Okay. When the sun's angle of elevation is 76 degrees, a tree tilted at an angle of 4 degrees from the vertical casts an 18-foot shadow on the ground. Well, if this is 90 and this is 4 degrees short of 90, that means that this is 86 degrees, right? So I have this triangle that's 86, 76, and 18. Well, I know this angle, 180 minus 76 minus 86 is 18. So I just take sine 18 degrees over 18, and I want to find the height of the tree, so that's this. Cross multiply 18 sine 76 divided by sine of 18, 56.5. Okay, I have a triangle, call it ABC. Angle A is 46, B is 105, C is 19.8. And I know angle C is 29, just subtracting it from 180. So I can use law of sines. I'm trying to find A. So sine 46 over A. 19.8 sine 46 divided by sine 29. Let's try again. Times sine 46 divided by sine 29. 29.4. And then the last one, triangle LMN. L is 42, M is 61, and angle N is 108. Find N. So I'm looking for this. Well, N squared equals 61 squared plus 42 squared minus 2 times 61 times 42 cosine 108. I just plug it in. 61 squared plus 42 squared minus 2 times 61 times 42 times cosine 108 is 7,068. And then I have to take the square root of that. 84.1. Okay, from a window 24 feet above the ground, so I'm going to just draw this building, and I've got this window here that is 24 feet. The angle of elevation to the top of another building is 38 degrees. The distance between the buildings is 63 feet. Find the height of the building. So, if I can find this, I'd add it to 24, and I know the height of this building. Well, that I would use tangent. So x is equal to 63 tangent 38, 49.2. But then it's another 24 feet. So the height of the building is 73.2 feet. Okay, I have a retake if you want to retake it. Otherwise, I'll just put whatever you got in. And I think I just recorded them all. Yes. Questions on anything you missed that you don't understand why you missed? I tried to put little notes in there as I was grading it, trying to help you. Unfortunately, right triangles will not go away. We're going to use them a lot in circles because we'll inscribe right triangles in circles. So just like everything just builds on itself, and each section we just add more things. So, okay, that's it.